So group two was automation, and that's actually pretty widespread. We actually started to delve down a lot of the automation stuff into the synthetic chemistry, and I guess that must be where people thought it was the most important to have some automation. So we talked about some of the things like maybe doing some automated synthetic discovery, like lab on chip type stuff. We talked about automated screening for chemical reactions that we want to use, which is actually something we talked about in the previous group as well. Getting some of the screening through and defining how many molecules we might actually use is something that came up with some generative AI potentially, so that we could automate some of the screening of molecules. Something else that I meant to write down. Let's see. I got it on here somewhere. How much to automate? So we did have a discussion about whether the automation, if you either go all in or part in, that it might not be as beneficial if you partially automate something. So we use the example of if you can automate one step and then you have a technician that takes a sample from that first step and moves it to a second instrument, that's not really automated. You have someone standing around waiting for step one to complete and then moving to step two. Doesn't really count. So to some extent, either automation, you're either all in or you're not. A big component of automation that we discussed is it needs to be in a mature technology. So a lot of the automation for synthesis, if you don't know what you're doing and what's going to happen, what the outputs are going to be, it's really hard to automate it. Again, I'm sensitive to this because I'm an analytical chemist, and synthetic organic chemists don't seem to think about us poor people at the end of the chain. So you make these new crazy molecules and you're like, well, just analyze it real quick. Oh, okay, come on. It's not that easy. I don't know what I'm looking for. I don't know what the interference are going to be. I don't know what the environment's going to be. And so the automation might come from more mature systems after some of the initial screenings actually been done. A big one that we did talk about though, and I really liked the idea, was some of the sample prep. So getting some of the sample preparation, some of the things that can be easily automated, we really, really should be doing that, especially if we're putting it in with consistent analyses. I would argue that automating some of the sample preparation can give you less pre-analytical error as well. So error that you're going to see that's not related to the measurement itself, but how the samples are being prepared and stuff. When you can automate that, you're going to be in a better way. A big one that we think would be really helpful for automation is if we're working across different labs as well. So if you've got multiple labs, multiple states, multiple continents working on things, getting some sense of automation and some ability to do that is going to give you more consistent results. I'm not going to say consistent because it's always different when you go from one lab to another, but more consistent results, and would really help in that cross-lab kind of validation study and things like that. I think that covered most of what we talked about?
Yes.
Okay.
Does anyone want to fill in anything?
By each lab automating, specializing in parts, automating certain parts, then you can end up getting everything automated, maybe faster than one lab trying to automate everything.
If we have the interface standard such that every automation is compatible.
Like labor division and automation.
Mm-hmm. Well, different labs can play to their strengths as well. I mean, even just from an instrumental standpoint, if someone has already invested in STM, then you don't necessarily need to if you can work with the lab that already has that capability. Yeah.
One thing I want to say is from my experience with data center automation and stuff, that automating a little bit is worth doing. Anything you automate is something that can't go wrong. So if you automate 5 things and there's 2-3 human steps in between, that means you have fewer places where things can go wrong. So the idea that automate everything or nothing is incredibly destructive to programs. That's not the right approach.
So I would argue, I'm not saying you're wrong, I'd say that it's application dependent. So something like synthetic organic chemistry where the output is very poorly defined, the automation is where you may miss errors. You may not see where you have problems in your system. And so you may actually get bad data out instead of, just because you have data doesn't mean that they're good. And so that's my concern from what I was saying. So absolutely, the things you can automate. That's why your point was well taken with respect to sample prep, for example. So something that you're going to do consistently no matter what, even if your analysis is a little bit different based on the exact material that you're going to be analyzing, that stuff absolutely. I was thinking more along the lines of some things, if you automate it before you're ready, it's not really going to help you all that much. And if you partially automate it to the point where you have intervention, I think about like active and passive tasks. So if you're watching a passive task be automated, but you have an active task that's going to come right after it, you're not necessarily saving a lot of time. With the caveat that when there's a lot of unknown or unpredictable behavior in the system that you're trying to automate. Does that make, okay. Engineering versus chemistry in a lot of ways.
Thank you so much.